Okay, grade 8, this is the other pattern question from the lockdown checkup. This question is the second half of the pattern question, and it says the pattern below is formed by rectangles. So can you see here? Here's one rectangle, okay, and so here was my original rectangle over here, and then somebody went and added like an H on it. So original rectangle, and then they added these two rectangles, and then we add another one of these. So you can see that every time we're adding a horizontal rectangle and a vertical rectangle. It says to you, complete the table to illustrate the number of rectangles per stage. So obviously in stage 1 there's one rectangle, in stage 2 there's 1, 2, 3 rectangles, then there's 1, 2, 3, 4, 5 rectangles. So if you have a look here, we could draw stage 4 if we really wanted. It would look like this. And then I would have 1, 2, 3, 4, 5, 6, 7 rectangles. Or what we could do is we could use the rule for patterns and say, okay, what is going on between every stage? Here we added 2. Here we added 2. So what is my constant difference? My constant difference is 2 every time we are adding 2. If we take two terms and we subtract them, remember subtracting is to find the difference, the answer is constant. So my constant difference is plus 2. Now it says to you, write the general rule that describes the relationship between the stage number and the number of rectangles used in the form Tn equals. So remember, this is what you have to remember with patterns. This stage number is usually called n, and then the number of rectangles is Tn. If you like, you can think of these as input and output, and it becomes equations with the form x and y. But for now, we just want to find the rule. So Tn is going to be equal to n something n plus or minus something, because this is how the patterns work. We know Tn equals something n plus or minus something if it's an arithmetic sequence. So if we have a look here, how do we check the rule? What do we do to check it? We say, okay, we take the nth term, Tn, or the nth term, and we say it equals to the constant difference multiplied by n plus or minus something. And then we substitute the values from the table. So Tn for stage 1 is 1, which is going to be equal to 2 times 1. So 2 times 1 is 2. Is 1 equal to 2? No, this is not a true mathematical statement, so we must make it true by adding or subtracting a number. So 2 minus 1 is 1. Then we check with the second term in the table. So when stage number 2, there are 3 rectangles. So Tn is 3. Stage 2 multiplied by n. 3 equals 2 times 2. 3 equals 4. No, this is not correct. We must subtract 1. Okay, so it looks like our rule is going to be Tn equals 2n. Remember, this 2 came from the constant difference, and then we found this subtract 1 by fiddling, by substituting and checking. So my answer is going to be Tn equals 2n minus 1. There we go, and that's how you solve these problems.